We'll do our time if we did nothing.
Okay, so when we come to sketching or graphing, the things we want to analyze, the first and foremost thing we want to look at is the domain. And the domain is affected in two different ways. One way the domain is affected is we know the denominator cannot equal 0. Okay, a radical in the numerator must be greater than or equal to 0. And what about a radical in the denominator? Can it equal 0? No, it must be just greater than 0. So these are all the things that affect our domain. Okay, the next thing we look at when we're sketching or graphing is, does the graph have any zeros? And the zeros of the graph happen when our graph crosses the x-axis. That's what a 0 is. So how do we know when there's a 0? We set the numerator equal to 0. And then the other thing we want to analyze for the zeros, is it going to be a bounce or a cross? Okay, next part of this. Vertical asymptote. Which I shortcut as VA, vertical asymptote. All right, so in order to decide if there's a vertical asymptote, what we're going to do is simplify the function. Then set denominator equal to 0. And then we solve. Okay, the next thing we're going to look for is a horizontal asymptote, which I shortcut as HA. Okay, and the way we're going to find the horizontal asymptote is we are going to take the limit as x approaches plus or minus infinity of f of x, our whole function. And some things will end up happening. If the limit is equal to 0, then horizontal asymptote at y equals 0. If the limit equals a number other than 0, then we will have a horizontal asymptote at y equals the number. If the limit is equal to plus or minus infinity, then there is no horizontal asymptote. I'll let you catch up. Okay, and the last thing we're going to analyze, does the graph cross the horizontal asymptote? So this is a big thing. A function will never cross a vertical asymptote. Never will happen. But it can cross a horizontal asymptote. So how do we figure out if it crosses or not? What we do is we set the function equal to the horizontal asymptote, then solve. I will let you catch up, and then we'll do some problems. Nico, could you take down that privacy border? Thanks. We good? Everybody caught up? So let's do some problems. First one. I'm going to ask us to analyze and sketch. And we are going to have y is equal to x over x plus 1. The first thing we're going to do when we have a rational function, what we want to do is we want to look at it and ask ourselves, is it possible to simplify? So we're going to say simplify if possible. Can I simplify this? No. Why am I not allowed to cross out these x's? Nico?
The x in the denominator is attached with the addition sign.
Good. The x in the denominator is a binomial. It's attached with the addition sign. We cannot cross those out. So we cannot simplify this. This is what it is. So the first thing we ask ourselves is the domain. Right? So two things essentially affect our domain. When there's a variable in the denominator, or if there's a radical anywhere, right? If there's a variable in the denominator, it affects our domain. If there's a radical in the numerator, it affects our domain. If there's a radical in the denominator, it affects our domain. So a radical anywhere affects our domain, and a variable in the denominator affects our domain. So in this scenario, is our domain affected? Yes. Why? There is a variable in the denominator. So we are going, I'm going to say denominator can't equal 0. So I'm going to take my denominator, x plus 1, set it equal to 0. So when will the denominator be 0? The denominator will be 0 when x is negative 1. What does that tell us? Our domain is restricted. Our domain will be x cannot equal negative 1. Can it equal every other number? Yes. It just cannot equal negative 1. All right, next one, vertical asymptote. Nope, vertical asymptote then zeros. So for the vertical asymptote, we're going to set the denominator equal to 0. So once again, we go back to our function, And we're going to say, okay, x plus 1 equals 0, x will equal negative 1. So that means we will have a vertical asymptote at x equals negative 1.
Yeah, look at Blizzard test. And like we already found the like x equals negative 1 from the domain problem.
You don't have to resolve it. You could just write it down. Okay, next we have the zeros. So remember, for the zeros, we're going to set numerator equal to 0. But we also have to ask ourselves, is it a cross or is it a bounce? Oops. So we take our numerator. What's our numerator? X. We set it equal to 0. How do we know, who remembers, how do we know if it's a bounce or a cross? Erin?
Cross is an odd exponent, bounce is an even exponent.
You got it. A cross is an odd exponent, bounce is an even exponent. Do we all agree this has an exponent of 1, which is odd? So is this a bounce or a cross? Cross. So we are going to cross at x equals 0. Okay, so now let's go on to our horizontal asymptote. Now this, out of all the things, this will have to make you think a little bit more. So for the horizontal asymptote, we take the limit as x approaches plus or minus infinity of f of x, of our function. So we are going to take the limit as x approaches plus and minus infinity of x over x plus 1. I'll let you all catch up and I'll refresh your memory. Okay. I know it was a while ago, but remember when we learned limit? Anytime we were taking the limit of to infinity or negative infinity to one of the infinities, what you would do is you would take the most influential term on top over the most influential term on the bottom. So what's the most influential term on the top? X. What's the most on the bottom? X. And then we would simplify. What does x over x simplify down to? 1. This means we will have a horizontal asymptote at y equals 1. Whatever that simplified down to be, it would end up being whatever that number is. Now, let's say we ended up getting infinity. What would that mean? No horizontal asymptote. If we simplified and we ended up getting infinity, that means there's no horizontal asymptote. All right, and the last part of this was asking us, does it cross? So now I'm going to say, does the horizontal asymptote cross? And what we do is we set the function equal to the horizontal asymptote. Right, what is my function? X over x plus 1. What did we say our horizontal asymptote was? 1. So we're going to set x over x plus 1 equal to 1. Now we solve. We have to actually solve this. So the way I'm going to solve this is, isn't this 1 over 1? When one fraction equals another fraction, aren't I allowed to cross multiply it? So that's what I'm going to do. I'm going to cross multiply. And when I cross multiply, I end up getting 1 times x, which is x, and then I end up getting 1 times x plus 1, which is just x plus 1. When I go to subtract the x's, what happens on both sides? They cancel. On the left side, I cancel to a 0. Does 0 equal 1? No. because this is essentially like a no solution, right? That means we do not cross the horizontal asymptote. Are we ready to sketch? Ready for this? Okay. All right, first things first, let's sketch all of our asymptotes. So we have, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, so we have a vertical asymptote at x equals -1. So we're going to go to -1, and how are all asymptotes drawn as? Dashes, you got it. So I'm going to draw a vertical asymptote at x equals -1. Do I have a horizontal asymptote? Yeah, at what number? Y equals? Not -1. +1, right? We have a horizontal asymptote at y equals 1. So I'm going to go to y equals 1, and I'm going to draw my horizontal asymptote. What's the next thing I'm going to plot, do you think?
The cross.
Yeah, the 0, right? Don't we have a 0 that we're going to cross at x equals 0? So we're going to go to x equals 0, which is right over here. Okay. Now it comes to the actual sketch. What you want to do is you use the vertical asymptote sort of as reference points. So you want to know what's going on to the right of the vertical asymptote and what's going on to the left of the vertical asymptote. Now what's really nice is I already have a point. That 0 is to the right of the vertical asymptote. And what happens is, because we're not crossing any asymptotes, I'm going to hug the asymptote, the vertical asymptote, and then I'm going to turn and hug the horizontal asymptote because I'm not crossing the horizontal asymptote. And our 0 was a cross, which means I'm not bouncing back down. So I'm going to go up, I'm going to cross, and then I'm going to hug. So we hug the vertical one and we hug the horizontal one. We're not crossing either of these. But now we're not very sure what's going on to the left, right, of the vertical asymptote. So this is where we have to test points. So the way you test the point, you take your function y equals x over x plus 1. And now I'm going to plug in an x that's to the left of the vertical asymptote. Well, we have a vertical asymptote at -1. Do we all agree -2 is to the left of that? So I'm now going to plug in a -2 for x to see what's happening. So when I plug in a -2 for x, I get y is equal to -2 over -2 plus 1. So we're going to get y is equal to -2 over -1, which is 2. What does that mean? That means when my x is -2, my y is +2, right up there. Now that I have an idea of the vicinity that my graph is in, where the point is, now I'm going to use my asymptotes to guide my sketch. Don't I have to hug the horizontal asymptote? And don't I have to hover and hug the vertical asymptote? But do I ever cross either one of those? No. So that's what's going to happen. So now that I know I'm in the upper left-hand corner, I'm going to hover over the horizontal and then turn up and hover over the vertical. And that is our sketch. Nico?
You just assumed it was like -2 because of the position it was near the asymptotes?
I didn't assume -2. I chose that number. So I just needed any number to the left of the asymptote.
Yeah, I see how
so
they're
you could have
parallel.
done -5, -10. I just chose the closest number that was smallest to the asymptote. But I couldn't choose -1 because we know we can't pick that asymptote. All right, are we ready to try another one? This is the last one, another one and the last one. Tomorrow we just do more practice with this. So the first thing we do when we look at our function before we start analyzing or sketching or anything, you want to ask yourself, is there any way I can simplify this? I know there's not, but let's say you didn't really realize that. You'd say, okay, well, x plus 1 squared is x plus 1 and then another x plus 1. And then x squared minus 9, isn't that a dots? So this would be an x plus 3 and x minus 3. Will anything cancel top or bottom? No. So were we able to simplify? No. So no, we cannot simplify, so we leave it like that. All right, what's the first thing we look at? Domain, you got it. So how do we look at the domain? What are the things that affect the domain?
Oh, I mean, I know the equation.
Okay.
I just like denominator cannot equal 0.
Good. Denominator can't equal 0. What's another thing that affects the domain? What's another thing? Not necessarily an exponent.
Variables.
A radical. A radical anywhere. A radical anywhere affects the domain. Is there a radical anywhere here? No. So we're just going with x squared minus 9 cannot equal 0. So we're going to factor this, x plus 3, x minus 3, and then x will equal -3, x will equal +3. What does that mean? That's what will make the denominator equal 0. So x cannot equal -3, x cannot equal +3. That's the only restrictions on our domain. All right, let's talk about a vertical asymptote. How do we decide on the vertical asymptote? Denominator, exactly. Vertical asymptote means the denominator will equal 0. Oh. Didn't we just do this? Yeah, so what do we know? We're going to have a vertical asymptote at x equals 3, but then another vertical asymptote at x equals -3.
Is it basically saying that you can't equal that because the asymptote's there, so there's no point there?
The asymptote is there
Yeah.
because of the domain. So actually the domain is first, and that makes our asymptotes be there. All right, next let's look at zeros. For the zeros, not Nico or Erin, who remembers what do we do to decide the zeros? Cross or bounce, but what do we do to figure out? What are we pulling it from? Good. We set our numerator equal to 0. Do we agree this is our numerator? So we're going to take x plus 1 quantity squared set equal to 0. So you tell me, cross or bounce? Bounce, because the exponent is even, exactly. So this is a bounce. Once we decide the cross or bounce, then we just take what's inside there, x plus 1, set it equal to 0. So x will equal -1. This is a bounce. So we do have a 0 at -1, and it will be a bounce. What's the next thing we look for? Horizontal. So remember, we're going to take the limit as x approaches plus or minus infinity of our whole function, which is the quantity of x plus 1 squared over x squared minus 9. Now remember, when we take the limit to plus or minus infinity, we take the most influential term on top over the most influential term on the bottom. But my most influential term on top is not x. Why is it not x? Not Nico or Aaron. Somebody else. Tell me, why is it not x? Gianna? It is x squared. Why? Good. Well, not distributed. We'd have to FOIL this out, right? If we were to FOIL out this numerator, x plus 1 plus another x plus 1, wouldn't that our leading one be an x squared? So keep that in mind. Our leading on top is an x squared. What is the leading on the bottom? X squared, which simplifies down to 1. So once again, we are going to have a horizontal asymptote at y equals 1. And now we have to ask ourselves, does it cross? How do we decide? Not Nico, not Aaron, somebody else. How do we decide if it crosses? What do we have to do? Luke? Good. We're going to set the function equal to the horizontal asymptote. So my function is x plus 1 quantity squared over x squared minus 9, and we are going to set that equal to 1. This is really 1 over 1 because when a fraction equals another fraction, we are allowed to cross multiply it. So when we cross multiply, I'm going to get x squared minus 9 is equal to x plus 1 quantity squared. I'll let you all catch up. You are not allowed to distribute this exponent. Can somebody tell me why we are not allowed to distribute that exponent? Why am I not allowed to distribute that exponent? Yeah, you have to FOIL because it's a binomial in there, because there's a plus sign in there. So you actually have to FOIL this out. So this would be x plus 1 times another x plus 1. So we're going to say x times x is x squared, x times 1 is x, 1 times x is x, 1 times 1 is 1. So now we're going to have x squared minus 9 equals x squared plus 2x plus 1. I'm going to try to get everything to one side. What's really nice here, what happens when I subtract the x squared? They cancel. So now I'm going to have negative 9 is equal to 2x plus 1. What do you think I'm going to do with that 1? Subtract it. This is just a two-step equation. Negative 10 is equal to 2x. So what does x equal? Negative 5. Because I got x actually equals a number, what does this tell us? We are going to cross. At what point are we going to cross? We are going to cross at negative 5, comma, what's the horizontal asymptote? 1. All right, let's sketch this. We ready to sketch?
Ready.
There's a lot going on in this sketch. first thing we're going to draw in are our vertical asymptotes, which are at plus or minus 3. So I'm going to go to positive 3, draw in a vertical asymptote. I'm going to go to negative 3, draw in a vertical asymptote. What else should I draw? What else should I draw in? A horizontal asymptote, yeah. So I'm going to draw my horizontal asymptote at y equals 1. Was there a 0? Was there a 0? Or did we? Yep, we did a 0. Where was our 0? Negative 1. So I'm going to go to negative 1. I'm going to put my point there. But, guys, what kind was this? A cross or a bounce? So what does that mean? What that means is I now know what's going on in this middle area. So the asymptotes help guide us. So I'm going to hover to the vertical asymptote, but then when I hit that negative 1, I'm not going to cross it. What do I have to do? Bounce back down, but then what do I have to do? Hover on that other vertical asymptote. So we are going to hover, hit, bounce, hover. Yeah, it looks like it. This is not enough. Because we've now created 3 sections. What do I mean when I say we've created 3 sections? The vertical asymptotes sort of guide everything. So we have to the right of one vertical asymptote, we have to the left of the other vertical asymptote, and then we have the middle between the 2 vertical asymptotes. There is something going on in all of those sections. Yes, Nico?
Test points.
Exactly. We now need to test points. So I don't need to test in the middle anymore, right? Because I have, between the 2 vertical asymptotes, I have my graph. But there has to be something to the right, there has to be something to the left. So now my vertical asymptote was at 3. I'm going to go 1 unit to the right of that. I'll go with 4 and see what happens. Oh, wait. There was something we crossed. That's going to help us. Where did we cross? Negative 5, 1. Okay, let's plot that point. 1, 2, 3, 4, 5, negative 5, 1, we crossed. Okay, but we don't know when we're crossing, are we coming from below it and crossing, or are we coming from above it and crossing? We don't know. So we still have to test points there. We do know we're going to cross, but we don't know if we're coming from the bottom to cross or from the top and crossing. So we still have to test points. So I'm going to test to the right of my first vertical asymptote. So I'm going to test 4. So when I plug in 4, I'm going to get y is equal to 4 plus 1, that quantity squared, over 4 squared minus 9. So I'm going to get 25 over 16 minus 9 is 7. I don't need an actual decimal. I just need an estimate. Do we all agree 7 goes into 25 3 times and then something?
Yeah.
Okay. So what does that mean? When x is 4, my y is going to be above 3. So 1, 2, 3, but I'm going to go above 3 because it's past 3, right? 3 point something. So 1, 2, 3, 4, 1, 2, 3, a little bit above 3. All I need is the general vicinity of where we're at. Do we now have an idea? Yeah. So we're in the upper right-hand corner, so I'm going to hug it, turn it, hug. All right, we need to figure out what's now going. Yeah, we now need to figure out what's going on to the left of the vertical asymptote. So my vertical asymptote's at negative 3. What point should I test? -4, right? That's a good point. Let's test -4. So we're going to go back in. Y is equal to -4 plus 1 quantity squared over -4 quantity squared minus 9. So now we simplify this down. Y is equal to 9 over, right? This is -3 squared, and then this is 16 minus 9. So it's 9 over 7. Is everything positive? Yes, everything is positive. All right, 9 over 7. Do you agree that's 1 point something something? All right, so now we're going to plot this. So I'm at -4, and then I'm going above 1. Because I'm going above 1 for the y, that tells us my graph is now in the upper left. So it looks like this, and it's going to cross it, but still hover after it crosses. Yes?
So for these, it could be like on the like above left, or it could be like on the bottom part of it as well. It just depends on how. Like,
yep, exactly. All right, guys, we're done. No homework. We'll practice more tomorrow.